I'd like to start with a quick review of our properties of exponents. We've already covered them. One of our properties of exponents said that if you multiply together two exponential terms that have the same base, you can simplify them by adding their exponents. So, i.e., if I gave you x to the fifth times x to the third, you would tell me the answer is x to the eighth. If you raise a number to a power to another power, that's the case where you're going to multiply the exponents. Notice how those first two properties actually look different. They are the most often mixed up properties. So if I gave you x to the fifth to the third, that would be x to the 15th. The next one, if I am multiplying two things together and raising it to a power, that's the case where I distribute my exponents. So if I gave you xy to the third power, you would tell me it is x to the third y to the third. When you have a base raised to a negative exponent, you can get rid of the negative exponent by writing it like this. So for example, if I gave you, let's see, 9 to the negative 1/2 power, you would tell me that's 1 over 9 to the 1/2 power. And hey, is it 9 to the 1/2 power the same thing as the square root of 9? Hey, look, I gave you one where we had to do a little more simplifying. If you divide two exponential terms, but they have the same base, you can simplify it by subtracting the exponents. So x to the fifth over x to the third would be x to the second. Now if I flip this over, instead I did x to the third over x to the fifth. Notice now that the bigger exponent is in the denominator. One of the things I usually like to say is you always subtract the exponents, but the answer goes wherever the bigger exponent is. Since the bigger exponent's in the denominator, your x squared goes in the denominator. So that would be 1 over x squared. We also have a distributive property over division. So if you have two things being divided inside parentheses being raised to a power, then you just distribute the exponent again. So if I do x over y to the third power, it would just be x to the third over y to the third. Now let's do a problem that we weren't able to do before because we didn't know about rational exponents. I'm going to write the 4th root of x cubed over the 8th root of x squared in simplest form. So to start this problem off, we're going to write the numerator and denominator in exponential form. So the numerator is x to the 3/4, and the denominator is x to the 2/8. Well, 2/8, that's just 1/4. And now that's one of my properties of exponents. It says as long as I've got the same base, I can simplify it by subtracting the exponents. So I get x to the 3/4 minus 1/4 is 2/4, and x to the 2/4 is 1/2. And you can either write it as x to the 1/2 or the square root of x. I actually do not care which form you put it in. If I want it in a particular form, I'll tell you. Otherwise, I'll take either. Now let's look at another problem that is easily done on the graphing calculator, but I want to do the long way so that we can so it gives us better practice than when we're dealing with problems that have variables in it. So 16 to the negative 2.5, I want to rewrite that in simplest form. So first of all, anytime you have a decimal exponent, I want you to change it back to a fraction. So negative 2.5 is the same as negative 5/2. Okay, now I have a negative exponent, so let's get rid of that negative exponent. We do that by rewriting this as 1 over 16 to the positive 5/2. Okay, let's remember that the denominator of that exponent is the radical. So that means that I can take the square root of 16, and then whatever answer I get there, I can raise it to the fifth. Well, the square root of 16 is 4. And then 4 to the fifth power, if I just shove it in my calculator, is 1024. This is probably the most direct way of doing this problem. The book has another way of doing it that I'll come back to haunt us. So I'll show this other way of doing it. After you rewrite this as 16 to the negative 5 halves, what you can do is you can rewrite 16 as a prime base raised to a power. If you think about 16 in terms of prime factorization, you find out that it breaks down into 4 2's. So it's really the same as 2 to the fourth to the negative 5 halves. Well, the property of exponents says I can multiply these together. 4 times negative 5 halves is negative 20 halves, or negative 10. So 2 to the negative 10th is 1 over 2 to the 10th. What's 2 to the 10th? 1024. So either of those ways is acceptable. All right, we'll look at this problem in two different ways as well. What's the simplest form of negative 32 raised to the 4/5 power? Well, let's look at this in terms of a radical. It's the fifth root of negative 32, and then we're going to take that answer and raise it to the fourth. Remember, we can take the fifth root of negative 32, because as long as the root index is odd, you can take an odd root of a negative. Well, it turns out that the fifth root of negative 32 is negative 2. And then negative 2 to the fourth power is going to be positive, because anytime you raise a negative number to an even power, you get a positive. And you get positive 16. Let's look at this from a different point of view. Instead, I'm going to rewrite negative 32 as a prime base raised to a power. Well, it turns out that 32 is 2 to the fifth power. What we find out is 32 is 5 2's. But in order to get negative 32, you must have raised a negative 2 to the fifth power. And then we're going to raise that to the 4/5 power. Well, the property of exponents says I can multiply those exponents together. Well, 5 times 4/5 is 4. And you end up getting negative 2 to the fourth, which is 16. So whichever way makes the most sense to you is the way that you're going to do it. Now we're going to make this problem a little bit harder. Let's talk about simplifying negative 8x square root of xy raised to the 2/3 power. The way we're going to go about simplifying this is we're going to start by getting rid of radicals and making them exponents. So the first thing that's going to happen is this is raised to the 1/2 power. Notice that both the x and the y are in the parentheses raised to the 1/2 power. Next, I am going to distribute that 1/2 power to the x and the y. The reason I can do that is because of the properties of exponents. Now, I want you to notice that there are 2 x's as bases. We combine those by adding the exponents. So 1 plus 1/2 is 1 1/2, otherwise known as 3/2. Okay, now that we've simplified what's inside the original parentheses, now we're going to deal with the 2/3 that's on the outside of the parentheses. That 2/3 distributes to everything inside the parentheses. So the negative 8 gets raised to the 2/3. The x to the 3/2 gets raised to the 2/3. The y to the 1/2, it gets raised to the 2/3. Okay, so now let's talk about negative 8 to the 2/3 power. This is the same thing as the cubed root of negative 8, and then we're going to square it. Well, the cube root of negative 8 is negative 2, and then negative 2 squared is 4. All right, let's go to the next part of the problem, the x to the 3/2 to the 2/3. This is the case where we multiply the exponents. Well, when I multiply them, 3/2 times 2/3 is 6/6, otherwise known as 1. So you have an x to the first. Now let's go to the y's. Y to the 1/2 to the 2/3 is going to be y to the 2/6, which reduces to 1/3. So it's y to the 1/3. So either you can give me this as an answer, or if you want to go back and change that y to the 1/3 to the cubed root of y, that is also an acceptable answer. But notice how I went and did the problem. First, I got rid of the radical and made it a 1/2 power. Then I distributed the 1/2 power to the x and the y. Then I had two x's that could be combined by adding their exponents. Then I dealt with the 2/3 exponent on the outside of the parentheses by distributing it to everything inside the parentheses. Then I simplified each of those expressions. I ended up in the end with my 4xy to the 1/3, or 4x times the cube root of y. All right, we have one last problem. Let's simplify 16y to the negative 8th, all raised to the negative 3/4. So nothing inside the original parentheses can be simplified, so I'm going to leave it as it is. What I am going to do now is I'm going to distribute that negative 3/4 power. And we did the same thing when we first talked about exponents. It's just now we're doing it with fractional exponents. So I've got 16 to the negative 3/4 power, and I've got y to the negative 8th to the negative 3/4 power. I'm going to start with this, only because when I multiply those exponents together, they're going to make a positive, which is awesome because I like to have positive exponents. Negative 8 times negative 3/4 is 24/4, which is 6. So that's going to reduce to y to the 6th. Okay, now let's go back to the other half. There are two ways you have of dealing with 16 to the negative 3/4 power. One way is to rewrite 16 as 2 to the 4th, and then multiply those exponents together, and you get 2 to the negative 12/4, which is 2 to the negative 3rd. And then 2 to the negative 3rd is 1 over 2 to the 3rd. And you have a y to the 6th, so this would end up being y to the 6th over 2 to the 3rd, which is 8. The other way that you could have dealt with 16 to the negative 3/4 power is you could have done the 4th root of 16 and then raise that to the negative 3rd power. Well, the 4th root of 16 is 2. And then 2 to the negative 3rd power is 1 over 2 to the 3rd, which is still my 1 over 8. Either way was an acceptable solution.